Hello, my name is Harrison, and today I'm going to be presenting to you my cognitive model of children and infants grabbing an object. So moving right into it, I have my model here that goes all the way from the initial visual stimuli of the scene all the way to finally grabbing an object. So part of this visual stimuli includes the target object to grab, the noise of the environment, as well as the infant themselves with their arms and hands. So this information is brought into sensory memory, and eventually the attention is distributed. So if the object has attention allocated to it, it will move forward onto working memory. However, if the object does not, it will eventually be decayed in this sensory memory system. And with successful attention to the target object, the noise will also decay. So moving forward to working memory, because of the capacity limitations of working memory, continued rehearsals are required, or continued visual stimuli of this object will keep it in working memory. From there, the decision can be made to grab the object based on the information about the stimulus, experience and known stimulus response pairs from long-term memory. If the decision is not made to grab it, this information will then decay. If it is made to grab it, motor control will begin. Whether or not this decision is automatic or goal-oriented based on a specific situation. So for motor control, there is one feedback loop between working memory and motor control, where information is continually brought in about the object and the child's hands as they are moving closer to each other, and this helps to guide this motor control. And so it goes back and forth as the motor control helps to change what is seen, and what is seen helps to guide motor control. There's also proprioception that helps to add an extra sense to this process. On top of that, information from long-term memory helps to guide motor control because of experience and known patterns that help to guide the child's movements. On top of that, in the opposite direction, as the child moves and watches their actions, experience is gained that can be used for later. And through this process, the child can grab the object. As one example, Timmy, a 3-year-old here, is looking to grab a red block. So the red block, as well as the environment around it, is brought into sensory memory, where Timmy then pays attention to this red block and so is brought forward into working memory, whereas the rest of the environment decays. So from working memory, Timmy decides to grab the block because it's both very interesting and because of his experience with other toys. As he begins to reach towards the object, the feedback loop begins where he sees his hand and the object moving closer together, and that guides him moving towards the object. He also uses his previous experience of manipulating objects to help guide his motions and coordinate his various fingers, hands, and arms for the motor control, and as well uses proprioception to help guide this even further, eventually grabbing the object. So the empirical support for this model, I use the various models of attention, but not specifically specify one, just to overall simplify the model and avoid any additional complexity that was not needed for the overall goal. For memory, I use the Atkinson-Shiffrin modal model of memory using sensory stores, working memory, and long-term memory. For motor control, I reference this article here because it helps to guide how visual cues help to guide motor control. And for automaticity, I use this one here because it helped learn, provide information on learning and how tasks can become more automatic. So for this model, it has some pros because I avoided some overcomplication and the risks of hyperspecification. But the downside to that is because it does simplify some elements of the cognitive process. The good side is that it represents development over time with experience. However, it might not fully represent this because of some highly automatic processes that may not engage at all with working memory like it does in my model. And then it's also good because it analyzes both perceptual and motor processes and how they interact. Now, for the next steps for developing this model is to validate the individual connections. For example, checking to make sure there's a valid connection with a feedback loop between motor control and long-term memory. Because there might be some aspects of experience that don't directly come from motor control, they might come more from after the goal is achieved. The analysis of success occurring might guide more learning rather than just during the task of grabbing the object. In addition, some more elaboration on certain elements such as attention and whether or not to make the decision should be made, perhaps to add that extra level of complexity, even if it may be a little bit overcomplicated. Getting a deeper understanding of this task may help to overall understand the situation and overall this cognitive process. Thanks.